Hello, everyone. A very happy morning, afternoon, and evening to one and all. I, Dr. Neha Tiwari, welcome you all as a host of ICICT 2022. Dear authors and invited guests, welcome to the technical session 6E. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you all are aware, we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances post-COVID-19 and making this conference more productive. Also, we wish everyone and their families a protected time. We hope you all will enjoy 2 days of knowledgeable and interactive digital sessions. One day has already passed. This is the second day of our sessions. There is a special note for the presenters. You will be given 10 to 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. I request while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we get started, I would like to introduce you all to the chair of this session, Professor Nilesh Modi. He is he's the director of School of Computer Science at Dr. Babasaheb Ambedkar Open University, Ahmedabad, India. Professor Modi is having a rich experience of around 12 years in academics and IT industry. His expertise include cybersecurity, data warehousing, and data mining, to name a few. I welcome you, sir. With your consent, I would like to start the proceedings of today's session, and we would like to call the first paper presenter for this technical session, Yogesh Kaushik, who's from Norway and is going to present his ideas on paper PSO-based improved surface roughness measuring approach of manufactured product within CP factory using T6 6068 aluminium. I now request Yogesh to take over the mic.
Yeah.
Thank you.
Should share my screen.
Yeah, we can see that. Please bring it to full screen mode.
Now it's visual.
You now have 10 minutes for your presentation. Thank you.
Yeah. Good afternoon, everyone. I am Yogesh Kaushik, a master student at Norwegian University of Science and Technology, and I am studying Master of Science in Sustainable Manufacturing. The title of this paper is a PSO-based improved surface roughness measuring approach of manufactured product within CP factory using T66068 aluminum. The outline of this presentation is a development of mobile cover inside the CP factory, a micro CNC in milling with aluminum T66068 alloy, analysis of product surface roughness using a stylus-based profilometer. Optimization is carried out using Taguchi orthogonal design and particle SWAM optimization, TSO. CP factory at NTNU. CP factory at NTNU. The CP factory stands for Cyber Physical Factory, which is an automated mini factory assembly line. The factory is a full-scale simulator of a real industry production with conveyor belt, robots, machine, autonomous transfer unit, and automatic bearing, with a large number of built-in sensor and associated software for simulation, planning, and analysis. All the machines are connected to PLC MES for management of order and its execution. The motivation of this work. As we know that CNC milling is one of the most common and widely used metal removing technology among the different machining approach. Product quality and machining cost are one of the important factors that are considered using the milling operation, and these factors are highly dependent on the surface roughness. From the past literature, it can be concluded that almost every work has only considered the surface roughness, the RA, for the surface feature analysis, whereas there are few other surface parameters that could be considered during the investigation of surface profile. The parameters such as roughness depth, mean roughness depth RZ, and maximum roughness depth RZ max. Hence, it is important to analyze the influence of different machining parameters on various surface roughness coefficients such as RA, RZ, and RZ max. This is the flow chart of this work. The process began with the CAD design of a mobile back cover. The design of this experiment has been provided by the company called Festo. The next step is to use Taguchi orthogonal design and L9 array to design the experiment with the different process parameter. In the third step, the machining has been done on the micro CNC milling machine in the CP factory. Then the different surface roughness coefficient are measured with the help of stylus-based profilometer. The next step is to apply optimization on Minitab and generate regression equation of the surface roughness. The next stage is to apply the PSO on the regression equation obtained from the Minitab. The result from the PSO are then compared with the best machining parameter combined. And the final step was to validate the process measure on the CNC milling.
I request you to please turn your camera on while presenting the paper. Thank you.
Okay. Is it on?
Yes, you're visible. Thank you.
Yeah, thank you. The experimental setup. For the experiment, Proxon FF500 BL 3-axis CNC milling machine is used combined with the NC-CAD 9 software. The CAD file is supplied by the Festo is used to generate the toolpath of the milling operation. The total of 10 casing from aluminum T660 set will be created. 9 for the experiment and 1 from the final verification of the result obtained from the PSO. Handy-safe E35B is used to has been used to measure the different surface profile coefficients such as RA, RZ, and RZ max. Material. Aluminum alloy 6068 T6 is used as a test work for the machining. The reason behind choosing this material is because this material is primarily used for machining in a high stress environment and have better machinability. The dimension of this, the dimension of aluminum block used for the experiment is 160 into 80 into 15 millimeter cube. This material is primarily used. The chemical composition of composition by the percentage of weight of the T6 is aluminum 95.1% to 98.2% with other elements like silicon, magnesium, iron, chromium, zinc, titanium, and copper. Whereas the mechanical property of the aluminum alloy T66068 is presented in the table below. This is the design. The CAD design of the mobile cover is presented in the slide, and this is the CAD for the back cover. When it comes to the tool, two tools are used during overall machining. The tools with different diameter. One is with the 4 mm diameter and other with 10 mm diameter. The 10 mm diameter tool is used to remove the extra material, whereas the 4 mm tool is used to make the pocket and different shape according to design. Both the tool have 3 teeth and are made of SSS steel. SSS material, sir. The experimental data. For this experiment, overall 9 mobile cover are produced. The experiment is designed by using Taguchi orthogonal array. The L9 array is constructed by using 2-factor and 3 level. The 2-factor are cutting velocity and spindle speed, while the 3 level for cutting velocity is 150, 200, and 280 meter per minute, and the 3 level for spindle speed are 3,500, 3,800, and 4,000 RPM. The depth of cut is kept fixed at 0.3 mm. In the table, you can see the L9 array the L9 array with the process parameter and the response parameter. The response parameter are the different surface roughness coefficient, that is RA, RZ, and RZ max. PSO, it stands for particle swarm optimization, which is used for the validation of the experiment. The optimization is carried out using Taguchi design of experiment, and further the obtained result is verified on the PSO algorithm. The PSO imitates the action of swarm of the bird. The algorithm began with the group of solution and a particle generated using random function. The general rule of PSO algorithm is all the particle flow the best particle and fly through the problem space. All the particles have their own position, fitness score, and the velocity that fix the flying direction of the particle. The two equation below is used to update the particle position, where BIT is the velocity equation for the velocity. This is the general flowchart of the working of PSO algorithm. In the step 1, the fitness function is defined, which is the regression equation obtained from the linear regression analysis in our case. The second step is to initialization of the swarm particle, which is 1000 in the case, and the iteration count is 500. The third step is to define the weight, which is kept as a random, and the value of C1 and C2, which were 0.45 and 0.55 respectively in our case. The fourth step is to run the PSO till the maximum iteration, which is till 500. During the run, the fitness function will generate a new particle, and the generated swarm particle is compared to the best obtained solution. In this case, the generated objective function is less. In this case, if the generated objective function is less than the best solution, then the new solution is obtained by making the solution a new global best solution. On the other hand, if the objective function is higher than the best solution, then the old solution is considered as the global best solution, and this process repeat until it reaches to the 500 iteration. The result and discussion of our experiment. Taguchi orthogonal array design is used to obtain the response table for mean and the signal to noise ratio. As the surface roughness is a minimization type of response, this means the smaller surface roughness value is taken as the best result. Hence, a smaller is better signal to noise is considered as the optimization approach. The mean plot is presented in the figure below, which states that the best RA value is obtained at the cutting velocity 150 meter per minute and spindle speed of 4000 RPM. And from the table, we can also say that the cutting velocity score ranks 1, which means that the effect of cutting velocity is higher than that of the spindle speed. The regression equation for all the response parameters, RA, RZ, and RZ max are presented in the slide. For RA, the regression equation is written in equation 3. For RZ, it's in equation 4, and RZ max is in equation 5. Whereas all these equations are used to generate the fitness function for the PSO, which is shown in the equation 6. The fitness function is made by giving equal weightage to all the response parameters.
You have last 2 minutes to conclude.
Yeah, okay. The result from the PSO. The optimal solution from PSO is not different from the Taguchi optimization. The response value is RA is equal to 0.369, RZ is equal to 1.805, and RZ max is equal to 2.4485, which are very closer to the experimental value. And the figure below is the convergence curve for the 500 iteration run by the PSO. This is the peak of the final product that came out from the milling. This one is the flat surface, and this one is the another surface of the black back cover. Conclusion: machining process optimization is carried out with the production of production in the CP factory. The product manufactured is a mobile phone case cover, which is recreated using micro CNC in milling facility and aluminum alloy T6068. The different process variables such as cutting velocity, spindle speed, and cut depth are considered for CNC milling, and various surface roughness parameters such as RA, RZ, and RZ max are considered as a process response. Taguchi orthogonal design is carried out using smaller is better signal to noise ratio for optimization, and linear regression is performed to obtain the response equation. The PSO algorithm is employed to verify the result obtained from the Taguchi analysis. And the research conclude that the better surface finish is obtained with the lower cutting velocity 150 meter per minute and higher spindle speed 4000 RPM. Future scope. This work is a part of ongoing master thesis, which is aimed to extend with additional process variables such as tool path, tool size, process variation in the future. And another one is the 3D profile analysis would be another area that will be explored further. This can help to analyze the counter analysis of the surface.
Thank you so much, Yogesh. Do we have some queries from the attendees?
Yeah.
No? Okay, so now I hand it over to Professor Modi. Thank you.
Yeah, may I know the applicability of this particular algorithm in a general scenario?
Sorry, can you please repeat the question?
Can you please elaborate what are the applicability of this algorithm in real world life?
It's like this algorithm solves a huge amount of problem in a small amount of time. Like it is less time consuming. Just for this experiment, the iteration count is 500 and it just took less than 10 seconds. So it saves time, and also it's quite it gives quite precise solution. For in case if we compare the solution with the Taguchi analysis and the solution from this, the both solution is very closer to each other.
No more questions? All right, so we move towards the second presentation of this session. I now call Libero Nigro from Italy to present his paper titled Performance of Parallel K-means Based on Theater. Thank you.
I try to share my video.
Sure.
It's visible?
No, it's not. Currently, it's not. I think it will take a few seconds.
Share video and choose that one. Please confirm me it is visible. Thanks.
It is. Now it is. Thank you.
Okay, my name is Libero Nigro from University of Calabria, and I will talk about software engineering work. But before entering the technical terms of my presentation, I would express my nearness to Ukrainian people for what is happening in these hours about this absurd invasion of Russia against a democratic nation. Okay. Now, what is the subject of my presentation? The subject of my presentation is an exploitation of today commodity, the multi-many core machine with shared memory, trying to exploit the high performance computing potential of this machine. And we try to exploit this computing potential by proposing what we call a lightweight parallel programming model. And we show an experience in applying our architecture, which is called the theatre, which is an actor system, to a parallel versus K-means clustering algorithm. And then we demonstrate some good execution performance which we achieved by executing such parallel version of K-means on large data set. Now, a few words about K-means, because it is well known. It is an unsupervised clustering algorithm, often used in machine learning, image segmentation, artificial intelligence applications, and so forth. What is the goal of K-means? K-means has the goal to partition n points in a space R raised to D, so an arbitrary number of coordinates, using K groups. K is fixed in advance. It is the number of clusters, okay? The goal of this partition is to have in each cluster, in each group of points, to have a great similarity. But this similarity instead is accepted among different groups. And a way to judge, to have the quality of the clustering is to evaluating what is called the sum of squared error, which is the objective function. Trying to minimize this function is the goal of K-means. K-means is preferred because it is simple in principle, and also has some efficiency because its complexity is related linearly to the number of points, the number of clusters, and the number of iterations necessary to go to convergence. Okay. However, in our experience, K-means has concrete application problems when we apply it to large data set in which we have a large number of data points, a great number of cardinalities, dimensions, for example, also a great number of clusters. And in the literature, all of this has motivated the recourse to parallel solution of K-means, which can be able to reduce the computational burden when we execute K-means on this kind of problems, okay? And in this paper, we propose an original parallel version of K-means in Java, which is based on our TH system, okay? Now, this is just a synthesis of the basic K-means algorithm of Lloyd basic algorithm, in which we initialize the K centroid, which represents the center of the cluster initially. Then the subsequent phase is a sign phase in which each point is assigned to its nearest cluster on the basis of minimal Euclidean distance. Then we update the centroid on the basis of the population of the various clusters, and then we continue by repeating from step 2 in the case some convergence criterion is not met. When it is met, we terminate the algorithm, okay? Now, from the literature, it emerged that the initialization of the K-centroid is an important problem, and that bad initialization can imply K-means to converge to a local suboptimal solution. And in the literature have been proposed a lot of these initialization methods, but some of them can have a problem to be applied in large data set due to the computational cost. And in many cases, in practice, the random method is used, which randomly select initially K points from the data set. But since these stochastic aspects, multiple runs in general can be necessary to select a good solution from the viewpoint of the objective function. Okay, we realized in Java an implementation, original implementation of K-means, which is parallel, and which is built around a master worker architecture. And you see here just a few classes of the implementation. And G is a global class which has all the parameters we use in our simulation. For example, the number of data points, the dimensions, the number of clusters, the number of core to use for the experiment. And in this picture, we tried to summarize in which way you operate the program, in the sense that it is the master actor which runs on a separate theater, which makes a certain number of steps which correspond to the step of Lloyd algorithm, and at each step it broadcasts a step message to all the workers, and from each worker it receives a done message which provides a partial temporary new centroid vector, and the master assembles the partial centroid and builds the new centroid vector. And upon this is a Basel determination function, which when it finds that the new centroids and current centroid are coincident, mathematically means are near to being distinguishable, the algorithm can terminate. Okay, this is just a view to give an idea, to give you an idea of the practical programming style, which is very, very clear in Java. And this is just a view of some experimental data which we achieved. And we worked on synthetic data set which were generated by a uniform distribution, and with the size ranging from 100K to 1000K, so 1 million data point, with 2 dimensions, for example, as just demonstration purposes. The number of clusters was fixed to 100 for demonstration, and the maximum number of iterations was fixed to 1000. But obviously, the parallel program can terminate earlier in the case convergence is detected before arriving to this limit. Okay. We made some experiment on a parallel machine, commodity machine with the 80 core, and for demonstration we choose to use 4 core using Java 16 version. And you see what we achieved when we when we increase the size of the data set, and you see that there is some irregular speed up, and this is due essentially to the use of the random initialization method, which implies also a different number of iterations which are required for converging. But what is important, considering that we use the 4 cores, is also in some cases the achievement of some superlinear speed up. Such superlinear speed up in reality was also registered in the literature in the processing, for example, of very large matrices or arrays, and are directly related to the exploitation of the L2 cache of each processor, of each core, and also in our case, in which we split the data set in segments assigned to different workers, we experimented the benefit of preloading the segment on the L2 cache, so that the access to the main memory are reduced in many cases, and this explains such a very good speed up, such super speed up. Today, we consider the implementation we achieved very promising, and we are moving to extending the approach by considering some complex stochastic or deterministic initialization method. We have implemented the Robin, which is well known to be a robust initialization method, which is robust against the avoidance of outliers to be chosen as initial centroid. And this method are also sensitive to the density of a point and try to choose the initial centroid far away each other. And you see also we are engaged in making a performance comparison of the actor implementation with the map reduce implementation we achieved in Java to see to what extent our implementation of based on actor is better. Then we move, also we intend to move, we have a plan to move to a distributed TEAC implementation of key means, because it would allow us the handling of very, very large data set, which cannot be stored on a local memory of a single machine. Okay, this is all.
Thank you
for
so
your
much.
attention.
Thanks a lot.
Any question?
I would like to ask Professor Nilesh.
No more question. No question.
All right. Okay. So that was an interesting presentation, Mr. Libero. Thank you so much for it. We
Thank
now
you.
move on to the next presenter, Aktiva Elf Istiko. I hope I pronounced your name correctly. He's from Indonesia. The paper title is The Successful Use of the Peduli Lindungi Application in Handling COVID-19, Indonesian Case Study. I would like you to start with your presentation, and you have 10 minutes for it. Thank you.
Okay, thank you. I'm sorry, can you see my screen?
Yes, that's visible.
Okay, thank you. Thank you, everyone. Good afternoon. My name is Aktiva Elvistiko. I'm from Indonesia, Muhammadiyah University of Yogyakarta. Can I start?
Thank you.
Okay. COVID-19 virus appeared in December 2019 and quickly spread worldwide. Even more than 121 countries, including Indonesia, were affected. The virus killed more than 400 people in China at the time. Several countries have shown interest in digital contact tracing applications since mid-March 2020 in Europe. In Europe, there has been widespread media coverage of academic and corporate developments and government agencies' statement and action regarding their interest. Indonesia has created an application called Peduli Lindungi, released by the Ministry of Communication and Information Kominfo in April 2020 to assist the government in handling the COVID-19 pandemic in Indonesia. Based on the background explanation above, the author wants to see the success of the Peduli Lindungi application in handling COVID-19 in Indonesia. I used theory by De La Valle. He said that technology can change the way many industrial sector and process operate. Indicator that can support the digital transition procedure are the value of the trust, 2, the transformative role of digital, and 3, the identification of digital strategy. My method is the studies use a QDIS approach to analyzing the NVivo plus 12 software. The data used is descriptive qualitative metadata, namely application data that explain the useful of the future in the Peduli Lindungi application and public response related to the application seen from Twitter data. This study focused on finding out how successful the Peduli Lindungi application is in handling the COVID-19 pandemic in Indonesia. We see in figure 1, number of users of Peduli Lindungi application can be seen from the data above that Peduli Lindungi application is based on the numbers of users. The graph has constantly increased in the last 12 months in the previous few months. In the figure 2, government's regulation governing the use of Peduli Lindungi application, it can be seen from the data above that the government has made several policies or regulations which discuss the use of Peduli Lindungi application. The Minister of Circular for utilizing state apparatus and bureaucratic reform number 20 of 2021 request of the Peduli Lindungi application in government agency throughout Indonesia. The Minister of Home Affairs instruction number 47 of 2021 requests the Peduli Lindungi application in many public sector like industrial area, hotel, public facilities, shopping center, and tourist extraction. Government police issues in the circular letter of the COVID-19 Task Force number 18 of 2021 also require the application of care to protect in the fields of land, sea, and air transportation. Next, health service stroke peduli lindungi. I can show you the table, the figure 3 comparison before and after the application of the peduli lindungi. And figure 4, we can see the peduli lindungi application features and function. The peduli lindungi application has many features that can help people's mobility in daily life and features that allows the government to track the spread of COVID-19. Case in Indonesia, the component in the peduli lindungi application are developed from time to time. Previously, it was only to download vaccine certificate, and now new features have been developed that will be useful in the community. These additional features are excellent because they help the community get optimal health service, especially amid the coronavirus pandemic. As is known, our face-to-face activities, especially in places with large crowd, should be avoided as much as possible during the pandemic to prevent the spread of COVID-19. In figure 5, we can see the technical error people talk about. It can be
You
seen.
have 2 more minutes to conclude. Thank you.
Okay, which shows the public response to use the of peduli lindungi application that most often appear is one application error reaching 52%, then data error getting 28%, and data leaks going 20%. It can be concluded that these 3 things are findings by research in the application of peduli lindungi application in Indonesia and become a conversation in the form of response by application user. The conclusion, the use of the peduli lindungi application during the COVID-19 pandemic in Indonesia was considered successful. The government efforts to create the peduli lindungi application have success in helping people mobility daily life and assisting the government in handling the COVID-19 pandemic. The success can be seen from the increase in the number of application users every month, the positive impact provided through the feature and function of the application, as well as the success of the government is convincing the public to use the peduli lindungi application. Meanwhile, in implementation, it turned out the complaints are still found from public response from the peduli lindungi users, such as application errors, data leaks, and user data errors. The criticism can be used as evaluation material for the government to the future improve the quality of the peduli lindungi application in the future. This research still has several shortcomings, starting from the source of application user data that cannot be obtained in the peduli lindungi application and limitation in collecting respondents to see the failure of peduli lindungi application. The research hope that there will be future research to discuss the weakness of the peduli lindungi application and develop further as an evaluation material for the government improving the quality of the peduli lindungi application. Thank you for your attention.
Thank you so much. Thanks, Akhdeva. I straightforwardly go to Professor Nilesh for his comments.
No question.
Thank you.
No question. No question.
All right, sir. Thank you
sir.
so much. So up next, we have Manuela Kader from Romania. She's going to present her views on challenges in deep learning applied to the knee joint magnetic resonance imaging. It's a survey paper.
Yeah.
I now request her to present her screen. Please start your screen share now.
Okay.
And you
Just
have 10 minutes for your presentation.
Just a minute, please.
Sure. Yeah, your screen is visible. Just start. Kindly start with the full screen mode. Yeah, thank you.
Yeah, just a minute, please. I don't know why it's not working, the F5. Now. Okay, hello everybody. Greetings from Transylvania, from Romania. My name is Manuela Kadar. Thank you for your presentation, Dr. Tiwari. And I would like to present first research paper that we started with my colleague, Alexei Botnar. Actually, I am an associate professor in the computer science department in the University of Alba Iulia, and my main interests are in artificial intelligence, computer vision, big data analytics. Alexei is a young orthopedic surgeon, also PhD student, starting his PhD on MRIs of the knee joint, and yeah, we are excited and happy to present our first survey in this area. It's something new, and let's say in the last 3 years there is a boom of publications in this domain. And I would like to focus and to point out some of the biggest challenges that we have identified in this area, in this new area of deep learning applications, with a special view on the knee joint. All of us know that the knee joint complaints are frequent in all age groups, and there are so many pathologies that, and also the anatomy is so complex that a thorough imaging and a precise imaging is required in all diagnosis of this joint.
We can't see the next slide. It's too
yeah,
big.
I will. I didn't.
Right. Okay, thank you so much. Thank you. Yeah.
Because I'm trying to introduce a little bit the subject. Don't worry. Yeah, MRIs, we all know, if we have done once an MRI, they are so time consuming, and always due to the fatigue of the doctors, there are a lot of misdiagnoses. So a deep learning approach would be very beneficial in this area. And now I present you a little bit in a few steps the structure of our paper. So we started with a survey of the literature on PubMed and Scopus, Web of Science. Then we made a chart of applications of deep learning to the knee joints. Also, we have analyzed all the types of deep learning networks that have been used to the analysis of the knee joint. And afterwards, we started to make an analytical framework, because we noticed that there are so many typologies. We designed an analytical framework to depict and to identify all these challenges. And then I will talk a little bit about the main challenges that we have identified, and of course, some conclusions and future work also for us as team, and also to other teams who are dealing with this subject. As I said, we can see that in the last 3 years, the publications arose tremendously in deep learning versus machine learning, also in knee MRIs, also in medical image segmentation. So there is an increase of publications. And we try to identify all the type of applications. You can see here in the left side of the image, the complex structure of the knee joint. So this is a musculoskeletal image of the joint. of course, the applications of deep learning are many, because some are dealing with the MRI technique improvement with the super resolution. Others are dealing with acceleration mapping of the image to reduce the time of the diagnosis and the investigation. Also, some DL-based methods are dealing with the restoration of the images from scarce data. Some other applications, and I can say that these are the most important applications of deep learning in this field, are image segmentations of the joint, lesion detection, lesion detection of all the structures, and not in the last place, very important are applications of visualization of the joint after deep learning techniques have been applied. You can see here in the left side collection made by Fyodor van Veen of all the type of neural networks that are used in the last time. There are a lot of architectures. And from all of this, the most important in the study of the knee joint are the deep convolutional neural networks. And here on the right, we have the general structure of a deep convolutional network applied, for example, for a classification problem with anomalies of the anterior cruciate ligament, meniscus, and normal knees. So this is a classification problem. Mainly this, yeah.
We don't see your slides.
You cannot see the...
No, they are not rolling.
Now? Can you see it? Sorry. Can you hear me?
The slide does not move, do not move. It is always the first slide.
It's always the same?
Yes, yes.
They are moving on my screen. Let me...
You can share it.
Yeah, can you see them now?
Yep.
Hmm?
Yeah, it is
Yeah?
now changing. It is now changing.
I will go one by one.
I interrupted you initially, but I thought you're not doing it purposely. So we had no clue why you're not doing it.
Yeah,
I pointed it out initially. Okay. Yeah. So you just conclude it in 4 or 5 minutes. We can see it, ma'am.
Yeah.
Please,
Can you see it?
like,
I will go one by one. So here we can see all the applications. I was talking, sorry, not to see them. Here are the typologies of the neural networks, and the main network which is applied to the knee joint is the deep convolutional neural network. Another structure very frequently used is GAN, generative adversarial network. And these kind of structures are used for generating new models and also in segmentation types. Now here you can see, after we made the survey, all the tasks that we have identified and the name of the models that have been used. As I said, they are mainly CNNs and GANs. The learning method is supervised learning, transfer learning, and unsupervised learning. And of course, the tasks, the objectives are detection, classification, staging of illnesses like meniscus tears, ACL tears. Also, another task is cartilage lesion detection you can see here that the networks differ a lot, and there are so many types. They all are CNNs, but there are so many variations of this type of networks. Also for tissue segmentation, there are a lot of supervised and unsupervised trained networks. For bone estimation, there are some interesting neural networks. A large category is the DL technology applied to MRI super resolution, and also for accelerating the parameter mapping. So we surveyed like, yeah?
You have last 2 minutes to conclude your presentation.
Okay, thank you.
Thank you.
So there are we surveyed like 80 papers, and we identified all these types of classification and types of neural networks, deep neural networks. Looking at the pipeline, we identified the challenges according to each phase of the pipeline. For acquisition, challenges regarding the dataset selection or the MRI quality. In the pre-processing, there are a lot of challenges regarding the data cleaning, the augmentation of the data set. Then in the neural model, what type of model should we select for which task? Also, there are a lot of challenges related to model validation, the performance, and the evaluation. And in the last step of the chain of the pipeline, there are some challenges with the data visualization. And one of the problems is the scarcity of data and availability of public data. Then another problem is there are a few clinical studies, interchangeability studies between various databases published by hospitals. Also, regarding the data augmentation, a technology which is very commonly applied is transfer learning from networks trained on large images from natural images to this kind of images, medical images. But there are some problems regarding the augmentation of data by applying the traditional geometric transformation, as they don't have meaning, let's say semantic meaning, medically talking. So this kind of augmentation should be applied with a lot of carefulness. Then we have related to the model, if we can find an off-the-shelf model which can be applied to let's say a data set of the hospital, but we notice that there are not such off-the-shelf models. Challenges related to image visualization are connected with the output. Usually the physician would like to see in the application, not the result from the black box from with the CNN, which are some figures. He would like to see the percentage of the lesion in various parts, and this is one kind of image visualization application developed.
The time is up. Okay.
Yeah, as conclusions for the future, it would be very much needed to develop a standardized framework for testing various DL-based technologies. So there is still a lot of work. The method is new and it's very promising, but it's still a lot of work to do in this field. Thank you.
Thank you so
Question?
much. Any
Yeah,
questions from the attendees?
yeah.
Okay.
I have a question.
So, Professor, so yeah, okay.
Yeah, actually, you conveyed that you find some challenges in DL-based implementation. Okay, so do you have something in your mind for the future course of action? How exactly you will be resolving those particular challenges or issues?
Yeah, data augmentation in the pre-processing phase, it's really challenging because of the scarcity of data. Usually in a hospital, you don't have but hundreds or couple of hundreds of data. Or for a successful training, you need much more data. So one solution would be to run and to make more samples through GANs, through
But nowadays multiple data sets are available. Okay, so there is no such scarcity of data for the research and any other aspects. Okay, so basically you may fetch out the things and you may get the things done by applying various data sets now.
Yeah, variational data set. Yeah.
Okay, thank you.
Thank you so much. Next in line is Patrick Brandner from Austria. His paper is Predictive Analytics and Intelligent Decision Support Systems in Supply Chain Risk Management, Research Directions for Future Studies. I would request Patrick to start with the screen share.
Yes.
And kindly limit your presentation time to 10 minutes. Thank you.
I will. So you should already see my screen.
Yes, please bring it to full screen mode. Thank you.
Yes. Do you now see the full screen mode of the presentation?
Yes, we can. We can.
Perfectly. Okay. So, well, a warm hello to everybody from my side as well, from Austria. I'm happy to have a short presentation about the paper that we submitted for this conference, focusing on predictive analytics and intelligent decision support systems in supply chain risk management. What we did is we did an extensive literature review to analyze research directions for future studies. I myself, my name is Patrick Brandner. I'm professor for data-driven management, especially in the context of logistics and supply chain management. And I'm working at the University of Applied Sciences, Upper Austria in Steyr. What is the background of the paper that we submitted and the presentation that I want to share with you? Basically, we have three areas, which is on the one hand, the technological domains of predictive analytics and of intelligent decision support systems, and on the other hand, supply chain risk management. Predictive analytics can be defined as that type of data analytics that makes predictions about uncertain events and about risks by applying advanced analytics. So basically by applying time series analysis, by applying clustering and classification, or normally prediction, we want to predict what will happen based on what we have learned from the past. So we examine the data for data patterns, we discover causes of events, and then we use these patterns to predict possible future events. This is what predictive analytics does. Then the second technological aspect is intelligent decision support systems. What is an intelligent decision support system? It is a system that utilizes advanced analytics and AI-based techniques to provide information to decision makers. Hence, it applies advanced and progressed analytic techniques, analyzing existing data and helping decision makers in organizations to form better based decisions in their business processes. What it requires, however, is that you have quite large amounts of distributed data available that can be analyzed, and it is always crucial to present the results in a way that it actually helps decision makers, the right decision maker at the right stage of the process, in the right form, in the right visualization. And these two technical domains have been brought together with the domain of supply chain risk management. What is that? Supply chain risk management is an approach of managing risks that occur, especially in decision-making situations in supply chain management, in which a decision maker either lacks information at all, he lacks information processing capabilities, he may also lack the actual decision objectives of his decision situation that he's in, and he may also lack the ability to predict possible outcomes and also the impact of actions and the effect of actions that he may take in supply chain management. So we wanted to analyze how predictive analytics and intelligent decision support systems are basically already applied in supply chain risk management. The reasons why we did this was that traditional supply chain management tactics and also traditional mathematical statistical approaches like normal forecasting, for example, will not be able to tackle the challenges and uncertainties that will be part of also current and much more future supply chains. So we have the need for an anticipatory, data-driven and intelligent decision support in supply chain risk management. There's high potential. If you look at literature, it is stated that IDSS and especially predictive analytics-based IDSS offers huge potential for supply chain risk management. However, in literature, we also find that the potential of predictive analytics has not yet been fully explored. There's missing evidence. Application studies are missing. We have applications, but those are limited and not presented in detail. Research so far mostly focused on technological aspects and neglected operationalization related aspects. So the technology, the specific approaches have been focused on, have been dealt with, but how to operationalize these technological solutions in organizations in supply chain risk management is still an open gap. And also, in general, that's a good statement. How you could summarize the current state of the research is that AI in STRM is still in its infancy, and there has a lot future research to be done in that context. The aim of the paper is basically to provide an overview of current research gaps and to propose future research directions. So we at our department, we are currently working ourselves at the intersection of predictive analytics, IDSS, and supply chain risk management. And we wanted to share the knowledges we gained by analyzing literature with the research community. So the questions we will address in this paper, and which I will also present the results, focus on the following two questions. First, which research gaps can be observed in current literature? And second, what are the possible research questions and directions for future studies at this intersection? So how can we start filling the research gaps at the intersection of these three concepts? The method we applied, as I already mentioned, was a systematic literature review based on the seminal approach by Webster and Watson. And we found basically that there are a couple of research gaps. We addressed the research gaps in each of the three areas. I would like to start presenting the results first from the point of view of the SCRM domain. And the summarized research questions that we found are, first, there is a lack of research on how to define requirements for predictive analytics from a STRM perspective. Predictive analytics is still largely underrepresented. The potential of predictive analytics techniques is not entirely explored. So also from this point of view, research is missing. And also what we found is that the applications of predictive analytics to manage supply chain risk still is at a low level. First research gap. Second research gap we identified for the STRM domain is that there's a lack of work dealing with the question of how to convert STRM-related problems into predictive analytics problems. How can you define data questions for predictive analytics algorithms from an STRM perspective? In this context, we also found that a holistic framework is missing, a framework that would allow to integrate PA and STRM, which is stated to be highly desirable in literature. And also, it was clearly stated that future supply chain risk management definitely needs to have enhancements, technological enhancements involved, especially in the form of incorporating predictive analytics and artificial intelligence. The second domain we analyzed was the predictive analytics domain. We also identified two main research gaps in this area. First, focusing on the full technical potential and also on the concrete technical specifications. In this context, research with a focus on STRM is low. We also found that artificial intelligence techniques and predictive analytics techniques in general have received little attention in STM, in supply chain management, and also in STRM research. So what we identify, or what literature definitely states, is a need for integrating PA algorithms that are able to deal with supply chain realities. That source specifically mentioned that classical traditional mathematical approaches are good for simple demand predictions, but are not able to integrate and address the complexities of nowadays and future supply chains. Hence, you need advanced analytics to deal with supply chain realities. Also, what we found in this context is that research has yet to embrace more sophisticated learning methods and also a more accurate profile of the impact and likelihood of supply chain risks has to be generated. Second gap we identified is that there's a knowledge gap among practitioners regarding the basics of PA and their potential in STRM, which leads to the fact that this PA has huge potential but is not used in practice due to low knowledge rates. Hence, we should try to keep practitioners more informed, to get them involved, and also to show the potential of predictive analytics in practice. In the IDSS domain,
just a reminder to you for last 2 minutes. Thank you.
Pardon?
Kindly conclude your presentation in
Yes.
2 minutes. Thank you.
Yes, I will try my best. From the IDSS domain perspective, the following gaps exist. First, we have also missing research regarding the implementation of PA in IDSS in supply chain management. So how to integrate predictive analytics in existing decision-making systems is also an urgent task in research. And second, specifically focusing on supply chain management, there is a lack of research on the coexistence, on the synergetic coexistence of artificial and human intelligence in supply chain management. That also involves the interpretability of the results produced by predictive analytics. The last research gap in IDSS domain is that, as I mentioned before, research on how to implement and operationalize intelligent decision support systems in supply chain management was also found to be low. So to sum it up, we have found several future research questions for the STRM domain. We identified a couple of research questions also for the PA domain and same for the IDSS domain. Hence, the results of our paper can be stated to focus on three main areas of research gaps arising from STRM, predictive analytics, and IDSS. The questions that we present in our paper can present a good starting base for future research, also from a business perspective, as well as from a data-driven and an IT system perspective. And there are a couple of starting points, which some of them are summarized here. More details are presented in the paper that we suggest to be good starting points for future research projects. Thank you.
Thank you, Patrick. I would straight away go to Professor Nilesh for his views.
No questions from my side. No questions from my side.
Okay. Thank you so much, Patrick. That was a very interesting presentation and good work that you've done so far. Thank you so much. So we now move on to the last presentation of this session. I call Sheetal Prasanna for her presentation. She's from the US and the paper title is Hyperparameter Optimization for Object Detection Network. Over to you, Sheetal. Thank you.
Thank you. Thank you for the introduction. It's not letting me share my screen until you stop.
Sure.
Okay. Okay, can you see the slides?
Of course, yeah.
Okay, perfect. All right, well, hello, everybody. My name is Sheetal Prasanna. I am a graduate student at the Purdue School of Engineering and Technology at IUPUI, and I'm working on my master's thesis with Dr. Mohammed El-Sharkawi. Today, I will be presenting to you one of my studies that is about hyperparameter optimization for an object detection network. Here's a brief summary of what I'll be going over today. We'll start with an introduction and the motivation behind the study. Then I will talk about the baseline and my proposed architectures. Then we will talk about my implementation, results, and end with some concluding remarks. As we all know, neural networks are gaining popularity in various different applications. This study uses neural networks for an object detection network in the application for automotive vehicles. Being able to accurately detect and classify objects on the road is the first step in developing self-driving cars. With any given neural network, hyperparameters become key features that are commonly used to improve a network. And so the goal of this study was to find a more structured method to choose optimal hyperparameter values in order to get the best performing network. There are two general methods for choosing hyperparameters in literature today. The first is with heuristics. However, heuristics tend to differ case by case. For example, something that works in image classification might not work for object detection. The second method is to do trial and error. But as we all know, trial and error can be both time-consuming and computationally expensive. We also found a lack of studies that focus on optimizing hyperparameters in object detection networks. However, there are a lot of studies done for image classification that clearly show the benefits of hyperparameter optimization. These benefits include improving accuracy, faster and more optimal convergence of the learning curves, and even a potential decrease in the time it takes to train a model. Because of this need for a more organized method of choosing hyperparameters, this study was conducted. The baseline architecture deals with the concept of sensor fusion. The sensors used are camera and radar. The idea is to project the radar data points onto the camera in the form of vertical lines that you see in this top left image. This image is called the radar augmented image and is then fed to the neural network for object detection. The data comes from the New Scenes dataset, which is one of the most popular automotive datasets that's available open source today. We get radar, camera, as well as LiDAR data from this. The New Scenes dataset also comes with a development kit that allows researchers to easily access and manipulate data. The data is also pre-annotated for 23 different classes. In the next slide, I have a brief flow of how the network works. We see that the image blocks are being fed through multiple convolution layers, while the radar projections are fed through multiple max pooling layers. Both of these are concatenated before the next layer. This leads me to my next flowchart, which is describing the RetNet architecture that's used and the 3 steps, which involve first, feature extraction, second, the feature pyramid network, and lastly, the detection head, where classification and regression losses are computed in order to update the weights. The baseline hyperparameters are shown in this slide. The learning rate was set to be a static rate. The number of epochs was set to be 20, with a batch size of 1. And the smooth L1 loss was used for regression, while a focal loss was used for classification. The performance of the network was measured using the standard mean average precision score. And with these baseline hyperparameters, this accuracy score was found to be around 36.7%. Next, I will be talking about the different methods of hyperparameter optimization that are proposed. All of these methods are based on the idea of overfitting versus underfitting. In the left image, we see evidence of underfitting where the training and validation data sets both perform poorly. Overfitting is in the middle, and this is where the training data set performs really well, but the validation data set performs significantly worse. A good fit is what we want to achieve, where both the training and validation data sets perform well and similar to each other. These are the 6 different methods that have been proposed in the study, and I will be going through each of these in detail in the following slides. First, we have the learning rate range test. The goal of the range test is to obtain the maximum possible learning rate for the network just before loss begins to diverge. From this maximum learning rate, we can then compute the minimum learning rate as a factor of 10 or 20 smaller than the maximum. And this provides us with the range of the learning rate for the network. Next, we have cyclical learning rate algorithms, which are based on the idea of having a dynamic learning rate instead of a static one. 3 different algorithms were implemented. The first one was based on the one cycle method that's discussed in one of the most popular hyperparameter optimization studies in literature today. The idea is to linearly increase the learning rate from the minimum to the maximum value for the approximately first half of the iterations. Once the maximum is hit, we then decrease it back to the minimum. The second implementation is called the triangular policy. The idea is to allow the learning rate to oscillate between the minimum and the maximum values for every other epoch. The final method is actually a novel method that's been introduced in the study and uses the ideas of the first 2 methods. We increase the learning rate from the minimum to the maximum for approximately the first half of the iterations, like the one cycle. But when the maximum is hit, we then oscillate between the maximum and 1 step below the maximum for the remaining iterations. Another implementation that was performed was to use different adaptive learning algorithms and experiment with them. These were the algorithms that were used. We used AdaGrad, AdaDelta, RMSProp, as well as ADAM, and optimizers were used to implement these. The model was trained twice, once with the default learning rate that comes with the optimizer, and a second time with the baseline learning rate provided by the network. ADAM was the optimizer that was originally used in the study. And lastly, we have the experimentations with different loss functions for both regression and classification. For regression, we use standard mean squared and mean absolute losses. And for classification, we use the popular cross entropy losses. This brings me to the results of my study. First, we have the learning rate range test, which gave us a maximum learning rate to be 1e to the -4. This test only took 11 minutes, and we were also able to compute the minimum for a factor of 10 or 20 smaller than the maximum value. Just training with this maximum learning rate gave us an average precision score of 50%, which already showed big signs of improvement, giving us a 31% improvement in the performance of the network. Early stopping was used to figure out the ideal number of epochs, and it actually matched the baseline with the 20 being the ideal number. Batch sizes was where we found a limitation in terms of system memory, and so batch sizes have been left for future study. Next, we have the results of the cyclical learning rate algorithms. As you can see from this table, all 3 of the methods showed an improvement from the baseline. However, the novel method that was introduced in the study gave us the best improvement and also the best accuracy score found in the study. The combination of the increasing linear rate and the oscillation provided an accuracy score of around 65.4%, which was a 56% improvement from the baseline. From this, we also found that the ideal minimum learning rate is a factor of 10 smaller than the maximum, rather than any other computation. For the adaptive learning algorithms, RMSProp outperformed ADAM, whereas AdaGrad and AdaDelta performed very poorly, most likely because of their aggressive nature. And finally, we have the results of the different loss function. Mean squared loss outperformed all of the other regression losses with a 48.5% map score. And we can see why in this plot. The mean squared is plotted in orange, and we can see that it converges faster and to a more optimal minimum compared to the smooth L1 loss that's in blue. For the classification losses, the baseline focal loss outperformed all of the other cross-entropy losses. This leads me to the conclusion. The goal of the study was to find a more structured way of choosing hyperparameter values in order to improve the performance of an object detection network. Most of the studies that we find in literature today are done for image classification, and so this study serves to fill the gap for object detection networks. Of all of the different implementations that were done, the cyclical learning rate, especially the novel method that was introduced, gave us the best improvement with a 56.2% increase in the mean average precision score. From these results, we can conclude that hyperparameter optimization is a great technique to improve an object detection network. So rather than treating it as an optional method, we should treat hyperparameter optimization as a step in the design process. Thank you so much for your time and the opportunity. Any questions?
Thanks a lot, Sheetal. Professor Modi, I would request you to ask her a few questions if you have.
Can you please explain some sort of real-life application that apply your research-related results?
So the results are applicable in two main areas. So especially for the automotive field, because as we all know, the self-driving cars, the development of self-driving cars has been gaining popularity. And so there are a lot of different studies that have been done on using the idea of sensor fusion for object detection. And so the results that hyperparameter optimizations can greatly, significantly improve an object detection network can be used by a lot of the studies that I've read in this area. And another general area is for machine learning itself. A lot of papers that I've read that talk about image classification or any type of network that uses the concept of deep learning, hyperparameter optimization is generally ignored or used as kind of a last resort. And so the evidence that we see in this study shows us that, we should be treating hyperparameter optimization as a step in the design process instead of just leaving it as, okay, we'll treat it as further study. And so for both of these fields, I think the results of the study benefit them in showing that, it's worth to take the time to optimize the hyperparameters because it does provide significant improvements for the network. I hope that answered your question.
Yeah, sure. Thank you.
Yeah.
Any more questions? All right. So with this, we have come to the end of all the paper presentations for this particular technical session. I now request Professor Modi to share his views regarding the papers which were presented in this session.
Yeah,
Over to you,
thank
sir.
you, thank you, Dr. Neha Tiwari. Actually, total 6 presentations were done in this session. One paper that was, I found some sort of technologically, it was not fitting into this particular session. Okay, so that was presented by Yogesh Kaushik, PSO-based improvement surface of necessary. All the other papers were very good. They thoroughly demonstrated the research work, what exactly they means planned and they have tried to carry out, and what exactly they have implemented. Some of the good papers that I basically found they were related to this performance of parallel K-means based on theater that has been presented by Dr. Libero Negro, as well as one of the other paper, two other papers that was predictive analysis and intelligence decision support system in supply chain risk management that has been presented by Dr. Patrick. And another paper that was the last paper, hyperparameter optimization of object detection network. So they have thoroughly presented the work, the research related implementation. Though the other papers are also good, but there were some study-based papers, and here all these 3 papers they have implemented the work. So I congratulate all the presenters for this particular presentation in the conference. And best luck for the future research work. Thank you. Over to you, Dr. Neha.
Thank you so much, sir, for sharing your views regarding the session. That would certainly help us in improving further. I sincerely thank our authors for their excellent presentations and their contributions in this session, and all our participants for being part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of ICICT 2022. I extend my special thanks to the session chair, Dr. Nilesh Modi, for sharing the session and sharing his words. As a token of appreciation to the chair on behalf of Team ICICT 2022 and Global Knowledge Research Foundation, I happily display the certificate of appreciation on the screen. Thank you so much for your valuable presence, sir. Dear all, I kindly request you to turn the cameras on for a quick snapshot of this virtual conference. Let's freeze the moment together. Let's have those beautiful, lovely smiles on our faces and make memories. I request everyone to kindly turn their cameras on for a few seconds. so that we can capture the memories of this moment for a lifetime. Thank you so much. Those beautiful, lovely, vibrant faces. Thanks a lot. We wish
so much.
pleasure is all ours. Stay safe. Take care. With those vibrant energies, I would like to take a leave from you. So Sonia has just, like, I can see her right now. Okay, thank you so much for your presence. Thank you, sir. Thank you, everyone.
Thank you very much.
Yeah.
Thank you. Thank you.
Thank you. Thank you so much.
Thank you.
Thank
Okay,
you.
bye-bye.
Bye.
Thank you.